All right. Hi, everyone. Um, Welcome back to another episode of Reality Check. This is me, Steven, your host, and today I'm joined by Dr. Hao Li and Dr. Craig Yu. Dr. Craig Yu, I think you guys have seen him for a couple episodes. He's my faculty advisor at George Mason University for Patriot XR. And Dr. Hao Li is currently a professor at UC Berkeley and founder of Pinscreen. Um, could you tell us a little bit about yourself, Dr. Lee?
Hi, nice to meet you. Yeah, so just to be more specific, I'm a distinguished fellow at UC Berkeley. So not teaching currently, but we're doing projects and conducting research. Um, yeah, just to tell you a little bit about myself. I've been working for probably over 15 years on digitizing humans. And at the very beginning, I was, working on doing my PhD on capturing performances with focus on real-time facial animation. As you know, some of the work actually led to the Animoji technology in the iPhone device. And I've been also working a lot during my early days at USC. So I used to be a professor at USC on digitizing high-end avatars. So we worked on, for example, Furious 7, reenacting Paul Walker in the movie. And um, in the past couple of years, my focus has been focusing on how do we use AI to not only democratize the process of creating entire humans, but also going a little bit beyond in just the problem of digitization. So how do we um, how do we really bring them to life, right? So how do we sort of like, and that's sort of like more of my focus right now. How do we um, add intelligence to the avatar so that they have more, behavior? I think now it's really a great time to work on that with all these advancements in deep learning. But at the same time, I'm also active in developing new techniques for neural synthesis and a lot of things with how do we use AI to improve the rendering pipeline for animation and also for not only generating avatars but general objects and 2D.
I took a look at your Google Scholar, and a lot of since I think 2011, you've been working on in some form or fashion 3D avatars, and how did you get into it?
Yeah, I think when I was when I was starting my PhD, I was actually that was the time when a lot of these. I've always been fascinated with computer graphics because you can create anything you want, and you can create new worlds and stuff like that. But when I started my PhD, that was back in 2006, 2007. That was sort of like the time where VFX has kind of already reached a point where the quality is nearly perfect, right? So there's almost nothing you can't really do. But one of the things is that there are a lot of things that you can't have untrained, unskilled, or regular people do, right? And that's actually where things becomes very powerful. I started to get interested in the computer vision side of things, which is how can you take physical things that are in reality and how do we digitize them? So I started with the scanning, dynamic capture. And when you think of dynamic capture, one of the most interesting things is how do you digitize organic things? And back then, digital humans were one of the holy grails that people have a hard time getting it right. And so I got fascinated with the problem of digital humans, and I was kind of like stuck with it since then. So I'm still working on it. So right now, if you look at the space of digital humans, I mean, you can give it like to some high-end VFX companies, and they can create some pretty good results. But then, even for video games, right? We've seen a lot of advancements like meta humans from Epic Games, but they're not perfect, right? They still look like um, especially if you don't render them in the right environment, they still look like video game characters. And I believe that with all these advancements in deep generative models, you have the ability to generate um, new avatars, like assets that are high quality, as good as ones that are created by humans or even scanned. And at the same time, you can improve the rendering capabilities that you have today.
Yeah, and like I saw like in one of your presentations, you were comparing your method to the typical like the typical standard where like I remember I think it was like Will Smith, he was in that little that dome with all the cameras, and like you're able to do it with just like a 2D image.
Right, that's the goal. And just to be clear, that we haven't really reached the point where we get exactly the same type of quality. So obviously, if you have like a high-end capture system, you get all, every detail, it's perfectly lit. But the ultimate goal is basically this. It's like, can you just take whatever picture of someone, or it doesn't have to be a photo. It can be a description of someone, and you
Mm-hmm.
can get um, to the results that you want, right? So the idea is, how can you create something without being constrained to this full capture environment?
Right.
Yeah. But the description, by the description of someone, do you mean like a general, verbal description of how someone looks like?
Yes,
And ideally, we will have AI to be able to generate, a person that matches that description.
I think so.
Yeah.
Because if you think about right now, I mean, people may not want to be themselves.
Mm-hmm.
They might want to, I mean, first of all, when you think about avatars, what the applications are, in terms of like telepresence or, metaverse things, then people might want to create an avatar for themselves. And they
Mhm.
might not want to be exactly how they look like. They might want to be a better version. Might want to be a completely different person. When you create content, you have different characters, so they're all different. And one of the things is that capturing a person is only one side of the things. The other side is, how do we generate a new person?
Mm.
And we've all seen like a lot of these recent, you know, advancements where people can generate very realistic humans from, or photos of humans from noise. Well, I think you would want to have control over what you're generating. For example, you tell like an oracle, create me a I don't know, African American person that
Mhm.
has I don't know, blonde hair and is this and this height, and has maybe smaller eyes, or has pointy eyebrows. Imagine if you can use high level semantics in order to generate that content.
Yeah, that's a very interesting direction. I could also imagine applications like you can turn the characters in novels just based on the textual description into some real characters that you can see
Yeah,
in virtual reality or augmented reality, right? And we are all
exactly.
fascinated by like superheroes in the novels, but like, okay, can I create my own superheroes just based on some description I write? I think that's very, very powerful. Yeah.
Correct. Yeah, yeah. And I think that, all these XR, or, applications, I think that's where I mean, obviously, take advantage of the most with the fact that your content is three-dimensional.
Yep.
Yeah.
Yeah, and you also talk about like creating fully autonomous humans, like a digital twin, so to
Right.
speak, and that involves more than just computer vision. Like like have you had any recent developments regarding like that the non CV side of things since?
Yeah. So definitely, it's a I mean, at least the way we engineer things now, is, I mean, first of all, what we're trying to do is we're trying to build a digital twin that simulates a digital human. It doesn't have like a own state of mind, and so that would incorporate like more advanced artificial intelligence research.
Mhm.
But from our standpoint, we're focusing on, there is a computer vision side, there's a computer graphics side, there's the way we engineer this, at least for now, is there is a multimodal way of side of things, which is, how do we combine audio processing, how do we um, how do we generate voice. So
Yeah.
obviously NLP is a very important component. So
Yep.
NLP would cover also responses to a person, but this is really an active research, and it's highly cross-disciplinary from the way I see it, because those people who work only on audio don't necessarily, or have probably not really looked at how this connects with the behavior
Mm.
of someone, right? So for
Right.
example, if I'm coughing, or if I'm like laughing really loud, I mean, what is how do you even describe that? And how does that even connect with the um, the behavior of the person, right? So, and even within graphics, you can see that there's also not that much research that connects even what the face does and the body. So there's really
Mm.
a lot of research and a lot of problems that need to be solved in order to produce something that is decent.
Right. Yeah. And then yeah, just getting all those models together, and like, yeah, like with cascade, like I'm doing like a cascade model for my research, and you just see the errors just compound and compound. So that's definitely a huge challenge.
Right.
So yeah, so I think I'd love to show, like, so I think the audience would be really interested in seeing like what we're actually talking about when we say that you're synthesizing a 3D avatar. So I think Dr. Yu, could you pull up the video?
Yes. Let me see. Do you want to turn on the audio of the video also? Like when I share my screen?
I don't think
Or
there's
I
audio.
Yeah, there's
So,
audio, right?
oh, there's, there's,
Yeah.
there's, there's,
Yeah,
there's.
yeah.
I
I
was,
think I think
yeah.
how can describe the audio, the video. So let me share my screen. Um, yeah, this one. You see my screen?
Yes.
Yes.
All right. So let's start from here.
Right. So this is a work from, I think, 2018. And one of the things that we're showing here is, so that's already not our work. So, but the work before is
Yep.
one
Starting
of the
again.
first methods that from a photo can actually generate realistic facial expressions using
Mhm.
a GAN, right? And we call it the method PAGAN. This is a different work. This work is how we use AI to, from the photo, extract the likeness of a person and then regenerate the 3D avatar.
Mm.
And what's interesting about our work is that we regenerate a person that is a neutral person, right? It's as if that person never made an expression. It's as if that person was captured under a diffuse control lighting. If it's black and white, it even generates the color for you. And the advantage of generating a neutral lighting and neutral expression is that you can insert that back into a virtual environment that has new lighting, and you can also animate the character. If you
Mm.
simply stick the photo of a person onto the mesh, then there is no way that I mean, you can insert that into a new environment, but it will look weird because you'll have inconsistent lighting on someone's face. So just imagine if wherever, Craig Daniels would walk around, he has the big contrasty shadow on the face, which would make no sense.
Right.
But now we can remove that, right?
Mm.
And the upper left guy is also very interesting because there's only um, part of his face that's visible, but the AI takes the likeness and
Mhm.
then can regenerate the whole face.
Mm.
Right?
Yeah, and Dr. Lee, could you go to minute 43:23? I think this is where Dr. Lee, you showcase the your wife as a 3D as a virtual assistant?
That's right.
4323, right?
Yes.
Okay. Yeah, we are getting there.
Right.
Ah,
So yeah. So
interesting.
right. So we created so that was like one of our first prototypes where we wanted to explore what happens. Well, we just wanted to experience it, right? So put all the things together. So a real-time system where a person talks to an avatar. We're not the first to do this, but one of the most interesting tests that we did that, I mean, at least it's the first I've seen, is that we've connected this with a freestyle chatbot. So it's not scripted. We use we developed a variant from GPT-2 that back then we didn't we didn't have GPT-3 yet. And with GPT-2, it basically just generated various responses. We added some stuff to basically make sure that the avatar doesn't say completely random things, that it has some consistency with it,
Mhm.
and has a little bit, better memorization of what she said before. But what's interesting here is that we combined automated speech recognition, so ASR, to parse what the person says, so I can talk freely, just like you talk to Siri and Alexa. It provides a more or less natural response. It's not perfect. It can still say random things, and it provides a response in the form of text. And from the text, we generate voice, so basically text to speech. And then from the voice, we basically animate the avatar, right? So back
Ah,
then, we have a system that can animate the face and also use a data-driven approach to generate some, simple movements on the body and try to add some coordination. Um, and then synthesize. It goes through a neural renderer, and this is a very compute-heavy process. So it all happens on the cloud. You have to think, right? So there is state-of-the-art speech recognition, state-of-the-art text-to-speech, state-of-the-art chatbots, and neural rendering, and um, classic computer graphics, real-time graphics. They're all combined together. So you need quite some compute. So that everything happens on the cloud, and you can use like your phone and run this. So that's like a full system we built back then. And right now we're improving individual pieces using deep learning to generate complete movements of the person, etc.
that's really cool. So is the facial expression, the animation of the mouth and so on synchronized with with
The
the
voice.
speech? Yeah, with the
Yes.
voice. Oh,
Yes.
okay.
It's actually
That's really cool.
driven by the voice. So
Different. Yeah.
yeah, so if the signal comes in, and it doesn't, and what's cool is that it doesn't matter what language I'm speaking.
Mm,
It can be any language. It's actually just extracting mouth spectrograms,
mm.
and from these mouth spectrograms, it generates mouth and facial expressions from that.
Wow. That's really cool. And you said it can run on the phone also.
It can run on the phone. It's actually not really running on the phone. It's just streaming, just
Oh,
like
streaming.
we're
Yeah.
using Zoom right now.
Yeah. That's
So
pretty cool. I think this can also be applied for augmented reality avatars, right? Like you may have a virtual character
Correct.
saying something, and everything is generated. Even the facial expression is generated, which is synchronized with the speech of the character. So
Correct.
pretty
So
cool.
right now, one of the problems so we can definitely animate a character in VR, but I think one of the problems with VR, I mean, in theory, you can render twice and
Mhm.
then you have it on your left and right eye. But the compute is quite heavy for
Mm,
all kinds of neural rendering. And I think for VR applications, right now for VR type of customers that we don't really focus yet on using neural rendering.
mhm.
One reason for that is that you're then limited to tethered VR because you need quite some compute.
Right.
And for actual commercial usage, there are two big problems. One is basically how much compute can you actually really afford on these devices?
Mhm.
And the second thing is the communication between things. So how would you transmit that?
Mm,
And the advantage of using traditional computer graphics, which is still, I think, for at least the next couple of years, is still relevant, probably even a decade,
Mm-hmm.
because you need to build entire worlds with a lot of users. And at least for now, there is not really a good way to do all these neural rendering computes at scale.
Hmm.
Yeah.
So you said for this application, so the rendering is it done on the server, which is
Every,
streamed? Yeah,
everything is
everything
done
is
on the
done on the
server.
server.
Yeah,
Gotcha.
Yeah, which is and yeah, and it is streamed to the laptop for visualization only.
that's right.
Okay.
And for this, you have at least two GPUs running at the same time.
Mm-hmm.
Oh,
One is for the graphics, and the other one is for the neural rendering. So the face is actually neural rendering.
Mm-hmm.
And but you have other things, right? You have more things that are using GPUs. You have the NLP, you have the chatbots, you have the
Yeah.
yeah,
yeah. That's super impressive, especially because everything is on the fly. Um,
Yeah.
yes, I mean, honestly, I remember. So what you said about this not yet being ready for commercialization, um, that time might be coming a little bit sooner than expected though, because I think Cloudcom just announced I think they just had a conference and they announced some improvements with some of their GPUs, and they also just partnered with ByteDance
yeah,
as well.
right. I think yeah, you're right. Um, so for XR applications in terms of I think one thing that's going to be relevant is edge compute.
Mm-hmm.
And Qualcomm is very active in low latency compute for these kind of solutions because um, you need to be able to do a lot of GPU tasks locally.
Yeah.
And you can't do everything on the cloud. This one is just doing everything on the cloud. But for XR application, you can't because you can't wait for the signal to go on the server and go back
Gotcha.
and wait for your device to even do slam and track your environment.
Hmm.
So everything needs to be separated out, and you need to have a solid infrastructure. But yeah, it's that would be the big benefit.
Yeah, yeah, for sure. Um, Now, like, do you see any? Because do you see any end-to-end solutions for like the CV part? Because I know like the model you have right now, you're using FaceNet, ResNet, and I forgot the other the after you produce the latent representation, it goes into one type of GANs, and then you produce the 3D model. Do you see like you yourself developing like an end to end solution sometime in the future?
Um, at least we're looking for certain components. It depends on the problem. I think for this specific problem, at least for now, we're still looking at it from a engineering perspective.
Okay,
And from an engineering perspective, I think there are actually more advantages in being able to separate into different components and train multiple networks, simply because type of training data that you can collect for each is very different. So at least right now, I wouldn't see how you can really train an end-to-end solution for that can do everything.
right.
I mean, even if it's just for generating the avatars, there are too many things, at least for now. And we're already, and there, even what we're doing right now, there's still other things that have, I think, higher priority for being solved. So I mean, it could be interesting from a research standpoint, what can be done end to end. But I mean, there's some benefits, but I think it has to be a much clearer benefit what exactly has to be end to end first
Yeah,
Mm-hmm.
before considering everything.
yeah.
Yeah.
Like you're more interested in optimizing the like in producing a better product than improving the accuracy by like say like 3%.
Right. I mean, yeah, I think that there's definitely this priority. But I think um, even in terms of research, I think what has more impact and what gets you closer to your goal? Because the goal is more, how do we build like this? How can I have this conversation we're having, and you think you're talking to me, and it's not even me. Then I think
Mm.
we're at a good place where we have something interesting. So what if I was actually an avatar,
Yeah.
and I might be doing something else, and you think you're talking to me, and I can even tell myself like, hey, can you uh, can you be more specific, like when you give your answers?
Yeah.
And then my avatar says, yeah, sure. And then it just like I think that so that's we want I think we want to build something um that sort of can reach that kind of level.
Yeah.
And obviously that's something that's is not something, one single people working on one single area can solve. That requires a lot of um engineering integration, cross-disciplinary research, and
Yeah.
a lot of things. And what we're doing is we're really putting everything. It's a bit like building a self-driving car. You
Hmm.
have experts that are building on how do we recognize streets, how do we recognize lanes, how do we do decision making. But then the self-driving car itself is like you piece everything together,
Mm.
right?
Right.
So, yep, yeah,
It's kind of like the ultimate goal is to pass the Turing test of human digitalization. So can you create a human avatar that is indistinguishable from a real human? I think that's probably the ultimate goal you may want to achieve, right?
um, yes. I mean, to some extent, I think for now, I think it's not just that. I think it's also how you use it. So
Hmm.
there are a couple. For example, if you want to create like an indistinguishable person, it's actually not that difficult.
Mm.
So if you look at recent, um, you know, deepfake or
Hmm.
neural rendering methods
Hmm.
where it's just purely 2D, they're hard to distinguish. And you can have
Sure.
like a person that jiggles around and then gives some answers. And I think the problem there to make it autonomous, I think it's more on the voice and the emotion side.
Hmm.
That is something that, like the avatars, they still talk a bit like this. Hello, my name is Hao Li.
Hmm.
It's kind of neutral, even though it's like getting better and better. But once you put it together with a human interface, then you see all the problems again.
Yeah.
And then there's no emotion. They don't even scratch their heads, right? With stuff like that. So just not normal. But I think for what you were talking about, right? So you were saying that what if we had, yeah, it's not just the photorealism. I think it's
Mm.
also how people can use it, because ultimately we want to build something that, I mean, if it's just photoreal, then the purpose seems more like you're trying to fool someone, but
Hmm.
or but I think we want to make avatars useful and
Hmm.
helpful for people. And I think you want to create avatars, for example, when you play a video game, even if it's just entertainment, right?
Yep.
Even if it's just entertainment, you want to play a video game where you have characters that you can interact with. But then
Hmm.
the question is, how many um, how many unique characters can you create? How can you direct how these characters are being created? Can you direct their behavior? Can you create a AR and virtual reality environment where you have, maybe you're trying to create a city, and you're
Hmm.
trying to create, a virtual New York, and then
Hmm.
you have a person go there and he familiarizes with the environment, and you have people that walk around, but you can sort of like, things that are more at this scale, and then
Hmm.
yeah,
So I think if we can have let's say, a virtual reality party room, like in the metaverse, so where you have real humans and also all these, avatars,
correct.
and you can interact with these people, and you cannot really distinguish between who are the real
Right.
humans, who are the real
Right.
avatars.
Right.
After like you talk with them, you play with them, you do different things, and you cannot really distinguish between the two. I think
Exactly.
you kind of reach the goal
Right. Right.
that we envision. Yeah.
Right. It would be actually interesting to not even have the need to create that, but
Mm.
the whole world, because this is just the visuals, right? So, I mean, what if you just have a chat room and you're talking to a lot of GPT-3s, and maybe you don't even know, right? Maybe you're just like chatting and then the conversation gets maybe boring, but maybe it's interesting. I have no idea. I think that would be an interesting test to see if
Mm.
uh, NLP research nowadays has reached a level where you can actually just go to a chat room and have entertaining conversations with you don't even know what it is, and
Yeah.
then and I think that itself would be kind of interesting.
Yeah.
And then, but once that is there, then you can easily imagine that you can create a virtual world where you can have just a friend or something, right? Or maybe it's animals, maybe it's a dog or a
Mm-hmm.
virtual pet or something that you can interact with. And um, the good thing is that, for example, I mean, this is like so people will have access to companionship without really having in reality. I don't know if that's good or bad, but it could be interesting. But what's definitely good, for example, is if you can have a virtual teacher for them, right? So not everyone can afford going to Berkeley or Stanford or maybe, but it, not everyone is as effective in a classroom with 200 people, 200
Yeah.
students.
Yeah.
What if you have individual lectures from a person? I mean, that itself, I think is cool. And what if you can have, you need a doctor, you need immediate assistance.
Yeah.
Do you talk to a phone where they say, oh, if you have that thing, press three. If you have that thing, press five. I mean, that shouldn't be how, it should be person that has full attention on what you need,
Right.
provides you exactly what you need. And the thing is, this is a problem where you can scale with humans, but
Mm.
you need to scale you. That's where AI, I think, could be very useful. Yeah.
Yeah.
It improves lives directly.
Yeah. I like your example. I mean, I never like those kind of automated help system, right? I want to talk to a real person to get assistance. Like every time I use those phones, automated help system, all I want to get to the button that will connect me to a real personal assistant
Right.
that can
Right.
solve my problem. So
Correct.
in this regard, like we want to achieve a similar goal in creating virtual avatars, right?
Right. Right. Right.
Yeah.
And that's, at least for now, this is the main difference between a real human having, you know, if you go to a store,
Mm-hmm.
there's I mean, why do you need to go to what is the difference between going to a physical store and buying something on Amazon?
Mm-hmm.
So, or eBay, right? So if you go to a real store, you have a person that can help you with what you need. So
Yep.
there's a direct feedback, and maybe there's a connection set, right? Because that person might remember, oh, you're our customer,
Mm-hmm.
and you come here to buy, that car, or
Mm-hmm.
you're here to buy this suit, and we
Mm-hmm.
know you, and we know
Mm-hmm.
what your taste is like, right? So
Mm-hmm.
you go to a restaurant, and then people, it's just as if you're like VIP, right?
Yeah.
And how can you offer that in an automated way?
Mm.
Right.
Yeah.
So you think there is a lot we need to do not only on the computer graphics side but also on the integration with other sides of the AI like NLP, and yeah, and so on, right?
Right.
Uh, so are you working on that in your company, like the
Yes.
integration of other
Yes.
AIs into the
Yes.
pipeline? Yeah.
Yes. Actually, our company is not just focused on graphics and vision. So
Mm,
we have been active on the NLP side since a few years.
mm,
And we decided to look into that very early on,
yeah.
because we see, I mean, our company is very R&D heavy, and it's not the typical startups where you have, a fancy app that,
Mm-hmm.
does a lot of things. But our focus is more on how do we solve the hard problems,
Mm-hmm.
and but also commercializing it,
Mm-hmm.
and working with very big companies that um, by working with us, get access to some unique technologies. And the type of problems we're trying to solve are somewhat a little bit different than how I was, as an academic. So when I was um, at USC, like the kind of work there, or even at Berkeley, right, the kind of work we do is very different
Mm,
because we're there. It's more like you need to focus on what is the next paper you want to
mm,
do, what is the next research direction, and you can't. It's interesting because normally you would think that as an academic you can work on whatever you want, but in order to do something new, you have to be different,
mm,
and you have to. It's not necessarily a working system that you have to build. It's more how can you have a new theory or a new thing, right?
mm,
And I think the kind of problems that we're solving, for example, at Pinscreen in a more industry setup is more like, well, that problem isn't really solved yet.
mm.
So our goal is not necessarily to always have a paper,
Yeah.
but no one is actually really looking at how do we, well, it's not no one is looking at, but people, even there, people take different approaches, right?
Mm,
So if you look at Facebook or Meta, they're taking an approach on, they have an interesting approach, right? So they have like huge, like almost an army of like really top researchers, but
sure.
they're immediately looking at the neural rendering thing, right? So
Mm,
everything, how do we do with neural rendering? But it's interesting because they're also focused on producing papers.
mhm,
So, but they also have a product side which builds things like Facebook Horizon. But
mhm.
then, I think there's a kind of like a
The
big
gap.
gap,
Yeah.
right,
Right.
between their R&D and their product.
Yeah.
And then, so I think in some ways we kind of fit in between,
Mm,
where we try to solve like a harder problem of what their product is solving,
mhm,
but at the same time, we have the expertise, but don't have the constraint that we have to. I mean, we somehow still publish because there is
mhm,
always something new that comes out,
mm,
but it's not necessarily a requirement for us. So we don't have
mm.
that constraint. Yes,
Sure.
and we can test directly with customers
Yeah.
because big companies want to get access to certain things that they don't necessarily have. So we can get very quickly feedback on is that even the right thing we're working on.
Yeah. That's probably something you cannot have as an academics in the university lab, right?
As a
The
pure
direct, yeah,
as a pure academic, right? But you can,
yeah,
I mean,
pure, yeah.
you can do things on the side, and you can also work with industry. So I think
Mhm,
people can do different things, but it's just like the way your team works will be quite different, right? So in university, I think your PhD students, everyone will have their thesis as a
yeah.
goal, but I mean, you can still make it in a way, for example, that you have 20 PhD students and they all work on your self-driving car thing, like, I mean,
Yeah.
some professors do that, but and everyone works on a piece and you try to, but it's different than if your main target is to build that whole thing. Yeah.
Right.
Sure.
And do you like probably you've gotten a lot of inquiries about like whether or not like your like a system like this could be abused, like if you had someone who has ill intentions that might have gotten their hands on their technology. Do you see a way to be able to safeguard against like abuse of maybe like generating like copying the likeness of someone that like a certain someone trusts, and then maybe like using that to their advantage?
Yeah. So there are actually even companies that entirely focus on how do you avoid abuse with
Mhm,
digital humans. But I think the only abuse right now that I see are like deepfakes, these kind of things. This is a real threat, right? So if if you create avatars, I don't see any abuse yet because no one is using it. So
mm,
I mean, no, VR users are very small, like tiny,
mm,
compared to people who watch things on their phone. And I
mhm.
think VR will come much later, like in 5 to 10 years, maybe.
Okay.
Right. So I don't think will have a big danger of VR in the next 2 years or 3 years. I think it first has to establish itself as a mainstream technology, which it isn't yet.
Mm,
Although it's kind of on its path, but there are too many other problems that need to be solved first. But
mhm,
I mean, then the main abuse, I think it's more data leaks. Like, actually, it's interesting. Facebook had recently this, um, what's that called? This extra feature in their metaverse application that people can't go too close because people are
Oh,
harassing
yeah,
them.
the comfort zone thing.
The
Yeah.
comfort zone thing, right?
Yeah,
And
yeah,
that's
yeah.
actually, I mean, that is kind of like, I think more of an, more of an issue, like what people can do with these things. And if you know Second Life, people, I mean, it's just nuts, like what people do in there. I mean, you have like that really crazy and perverted things that are going on, and it's completely unregulated, right? It's just like the internet. But if you think about, um, you know, on the technology side, I think that the only big threat right now is like when people try to do deepfake kind of things, like
Mm,
manipulate performances of people, making people say other things.
mhm,
That component of it, which many of the researchers developed just to create better avatars, is,
mm,
I think, more of the danger thing. So, what do we do on that side? I mean, obviously, I'm quite active in educating the public on like that this kind of technology actually even exists.
mm,
We're working with DARPA. I mean, we actually are funded by DARPA and work on new technologies to detect those things, right? So we're looking at, and that's very research oriented, and it's mostly through collaborations with Berkeley on how do we prevent the spread or prevent people from creating fake ones, right? So once you can
mm.
detect them, it will already help a lot with, for example, if you just label it, this is a deep fake, right? Imagine now you're watching the Ukraine crisis. Um,
Right.
like the states have full access of what people can see. They have the ability to control whether it's actually on social media. If
Mm,
you don't comply, then you get punished. So then, if you have access to that, then you have the ability to. Uh, I mean, what would prevent the Russians from making um Zelensky say something outrageous, right?
mm.
Uh,
Right.
Nothing. I mean, you can produce that, right? And everyone would then you can do that, and on the other side too, right?
Yeah.
You can, right? You on both sides. I'm not even pointing a finger at a specific person right now, but
Mhm.
this could become a form of information warfare.
Right.
Yeah. That's definitely
So
some.
yeah,
Oh, go ahead,
yeah. I
Doctor.
think distinguishing what is fake and what is real is super important, right? Like,
And what is good and what is bad.
uh-huh. That's more
Right.
controversial. But I think like letting the public know
Correct.
what is real, what is fake is important, and the judgment is up to them, right? So
Right.
yeah,
Yeah.
so
But
interesting.
yeah, no, definitely something to think about. I think that's all the time that we have. Thank you so much for joining us, Dr. Lee. Is there any new developments that you want our audience to know about?
I think they should stay tuned. So one of the big things that we're going to launch very soon is we're going to have a new version of our avatar digitization. It's under heavy development.
Hmm.
Actually, next week we're going to have a demo in partnership with Zozo at South by Southwest, where we're going to demonstrate a virtual try-on solution that uses our latest avatar digitization technology, and we actually built the entire um, software solution.
And you said people can attend virtually.
It's actually a physical event.
Okay.
Hmm.
I'm not sure what people can actually see virtually, but yeah, I think it's going to be a lot of fun. And yeah, and watch out for more.
Oh, nice. Well, I would love to attend, but I'm over here in the UAE, so
It's in
maybe
LA,
next
right?
time.
No,
It,
no, it's in Austin. I
Austin.
think
Oh,
I think
okay.
in general the attendance is probably not as big, obviously not as big as before
Hmm.
because of the pandemic. Yeah.
okay.
Right.
Awesome. Well, thanks again, Dr. Lee. Thanks, Dr. Yu, for joining me as well.
Thank you.
Yeah.
Yeah.
Tune
Thank you so
in.
much for having me.
Of course. Of course. This is a lot
Yeah.
of fun.
Thanks.
Yeah. So, thanks for joining us, everyone. Please, like always, smash the follow button. Turn on your notifications, and we'll see you next time.
Yeah.
Thank you.
Bye, everyone.
See you. Bye. Take care.